Miss Lee's Chemistry Academy, Lab 10, Le Chatelier's Principle. Investigation. A student is assigned the task to create a display of rainbow colors by changing the concentration, pressure, and temperature of chemical systems at equilibrium. Le Chatelier's Principle. If a change in concentration, temperature, pressure, or volume is imposed on a chemical system at equilibrium, then the equilibrium shifts by changing concentration or pressure to counteract the imposed change and establish a new equilibrium. Equilibrium 1. Bromothymol blue, or HB, is an indicator that appears yellow in the acidic region and blue in the basic region. By adding NaOH, OH neutralizes the H+. As H+ ions are removed, the reaction shifts to the right to produce more H+. The color will turn blue. Through adding HCl, the concentration of H increases. The reaction shifts to the left to consume the additional H+ to produce a yellow color. Through adding NaCl, no shift occurs and color remains green. HB to H plus B minus. This photo shows some of the test tubes that we're creating from shifting equilibriums. Equilibrium 2. The equation shown above is the equation for this equilibrium reaction. When iron 3 chloride is reacted, the concentration of iron 3 increases. The reaction shifts to the right to reduce the concentration of the iron, which in turn turns the solution red. When KSCN solid is added, the concentration of SCN- increases. The reaction shifts to the right to reduce concentration of SCN, which turns the solution red. When sodium phosphate is added, iron 3 hydroxide solid forms. The concentration of iron 3 decreases. Reaction will shift to the left to produce more Fe3+, which in turn turns the solution yellow. Fe3+ plus SCN- to create FeSCN2+. This photo shows some of the test tubes that were created from shifting equilibriums. The cloudy yellow test tube was created from this shift in equilibrium. Equilibrium 3. Copper sulfate is mixed with ammonia. The ammonia and water forms ammonium and hydroxide ions as shown in the equation below. When ammonia is added in excess, copper hydroxide solid dissolves to form complex ion as shown below. The addition of hydrochloric acid neutralizes the ammonia. The removal of ammonia causes the reaction to shift left, forming copper ions with light blue color. Cu2 plus 4NH3 to form CuNH3 2 plus. This photo shows some of the test tubes that were created from shifting equilibriums. The light blue test tube was created from this shift in equilibrium. Equilibrium 4. The equation shown below is the equation for this equilibrium reaction. From the addition of hydrochloric acid, the concentration of chloride increases, resulting in a reaction shift to form green color. The bright green test tube was created in this equilibrium. Equilibrium 5. The equation shown below is the equation for this equilibrium reaction. From the addition of sodium chloride, the concentration of chloride increases. The reaction shifts to the right to form blue. From the addition of water, the product, the reaction shifts to the left, resulting in a pink solution. From the addition of silver nitrate, which causes silver chloride to form, the chloride ions are removed and the reaction shifts left to form pink. Then, if you place the test tubes in a hot water bath, thus increasing the temperature in an endothermic reaction, the reaction shifts right to form blue. Placing the test tube in an ice bath decreases the heat. As heat is removed, the reaction shifts to the left to form pink. CuH2O 6 2 plus 4Cl- plus heat to form CuCl4 2- plus 6H2O. The light pink and dark blue test tubes were created in this equilibrium shift, as shown in the photo. Equilibrium 6. Placing carbonated soda drink inside of a syringe with a few drops of methyl red indicator produces the following equilibrium. Pulling the syringe out releases pressure. Carbon dioxide leaves the solution. The reaction shifts to the left to form a yellow color. Pushing the syringe increases pressure. Carbon dioxide is dissolved in water to form carbonic acid. Thus, the reaction shifts to the right to form a red or orange color. Pushing syringe increases pressure on carbon dioxide gas above a soda drink. This photo shows the color change to red inside of the syringe. CO2 plus H2O to form CO3 2- plus 2H+. All three of these test tubes were created from this equilibrium shift. Rainbow colors. This last photo shows all of the colors created from the equilibrium reaction shown below.